Lumbu, Sochi Technical College. Welcome to another discussion in site surveying. This topic is intended for those who are doing technician diploma in construction technology. And our topic today is going to be traversy. At the end of this lesson, you're supposed to define traversy, and also you're supposed to state the purpose of conducting a traversy. Also, you're supposed to mention and describe the main types of traversy and also the principles of traversing. The students are also expected to state the factors that will influence the choice of traversy stations. And finally, they are supposed to describe the linear measurement and the errors associated with that linear measurement. A traversy consists of a series of straight lines connected to each other, each line having length and direction. Therefore, traversy lines are vectors because they have the direction and the magnitude. The points defining the ends of the traversy lines are called the traversy stations. Purpose of conducting the traversy. We normally need to conduct traversy because we want to locate or establish the boundaries for the property. Assuming that you've purchased the land, then you would want to know the actual location of the boundaries, the corners, and other things. So the details of the corners and also the distance between the corners can be determined by conducting a traversy. The other reason is to determine location and construction layout surveys for the highways, railways, and similar works. So traversy is very important in that aspect. Of course, we'll be discussing this as we go along in form of the calculations and other discussions. The traversy acts as ground control surveys for photogrammetric surveys. Types of traversy. Normally, when you are conducting the traversy, like I said, based on the functions that based on the function which you are conducting the traversy, you can also as well devise the type of the traversy that you normally use. In fact, we have two main types of traversy. We have the open traversy. This starts at a point of known positions and ends at a point of unknown position. Another type of traversy is the closed traversy, which starts at the known position and ends at a known position. So closed will start from a known point and ends at a known point. So closed traversy normally is further categorized into two groups. You have the linking closed traversy and also the loop closed traversy. So if we are to further discuss the closed traversy, like I said, it takes two forms of configuration, that is the link or connecting. So you can either say the link traversy or connecting traversy. Other authors will use the connecting traversy and others will use the link traversy or linking traversy. So in the linking traversy, it's like you have a one-way, but you start from the known point and then you end at a known point. Of course, the starting point has got the details which are known, which have already been surveyed, and also the closing point, which have got the surveyed points, which are also known of their details. So the checks can be carried out when using this kind of traversy, because you start from a known point and then you end at a known point. So it is easy for this to determine whether your survey was accurate or not. As you can see on the diagram on your right hand side, you will see that you have the triangular points and the circular points. So on the triangular points, we are showing the triangular point shows those points that have got the known positions, like point A, point B, and point F. These are the known positions. And the points that have been established are the points C, D, and E. So these are the new points that have been established. So the accuracy of these points that have been established will depend on the closing of the known points. That is, if we are starting from A up to F, if our surveying closes perfectly at point F, then we will know that the point C and D have been surveyed correctly. Otherwise, you may need to do the retraversing or to conduct the exercise once again. So of course, whenever you are doing the traversing, you start from a known point, and the lines are supposed to have a direction. As you can see in this diagram, we are starting from point A. Of course, point A and point B are known points. And this leg, the traversal leg, of course, the distances like AB, they are known as the traversal leg. So the leg AB has got the direction, and also it has the magnitude in this case as indicated by the north point. So whenever we are determining the direction of the traversal leg, we actually determine that traversal leg by determining the whole circle bearing of that line. In this case, it means that we will start from the north and turn clockwise until we face B from A. So that will be the bearing of the line AB. And these other lines can be the bearing of the other lines BC, CD, DE, and EF can be determined based on the angles of deflection and whether they are deflecting to the right or to the left, but you can determine the direction of those traversal legs. So we normally use the closed traversal in those areas that we need higher precision as opposed to maybe the preliminary survey. So we can just use the open traversal in those areas that we'll just conduct the preliminary surveys. That is to determine how the site is and what other things that you need to take into account before you start doing the actual precise or more detailed survey. The other configuration of the cross traversal is the polygon traversal. This forms a complete circuit that is returns to the starting point. As you can see in this diagram, we are starting from point A, going through B, E up to A again. So the points that are being established in this case are points B, C, D, and E. So this is a loop traversal. Of course, like I said, that the points containing the triangular points, they are those points indicating the known. So we can differentiate the newly established points and those that have got their details known by the way we determine the nodes of the lines. So if we have the circular nodes, those are points that we are establishing, and those that have got the triangular nodes are the points that have got the known details. So for A, we know the details of A. We don't know the detail of B, C, D, and E, hence conducting the traversal to establish these points. Checks can be carried in this kind of traversal. It's easy to carry out the checks in this kind of traversal because you start from a known point and then you end at a known point. So therefore, it is more precise. That is, if we are using this kind of a traversal. So for example, if we have this diagram that has been surveyed, the figure which shows a closed polygon, and this polygon has got 4 sides. We have A, B, C, and D. So we can do the preliminary check of a closed polygon to determine whether our angle observation or maybe the traversing was done in a correct manner, or maybe the traversing was done accurately. So you can do the summation of the internal angles by following the formula which is on the left hand side, the one that I'm just showing. You could follow the formula which is n minus 2 times 180 degrees. That is, if a figure has got like in this case 4 sides, it means that our n is going to be 4 or alternatively angles. So n represents the number of sides or the number of angles that a closed polygon has. So in this case, we'll say 4 minus 2 times 180 degrees, and this will give us 360 degrees. So if for any other reason that if we have surveyed a land, like if we assume the polygon ABCD is the land that we are surveying to determine the boundaries, and if we happen to add the internal angles so observed and they do not add up to 360 degrees, then we need to do the adjustments. Of course, you don't have to do any adjustment for any traversing exercise. There is a limit for that. If the error goes up to 1 degree, then it is advised, or it is a good practice to redo the traversing. Otherwise, the whole exercise was a mess in this case. So we normally do the adjustment of the angles where maybe the difference is just some few seconds, because how experienced you may be, it's very difficult to come up with a perfect polygon after the traversing. So we determine the adjustments whenever you have a difference which amounts to some few seconds and not necessarily minutes or maybe degrees of an angle. So the adjustments is normally distributed equally. Let's assume that maybe the difference between the angle that we find whenever we are using this formula, like in this case, if it is 360, and the ones that we have surveyed and we find out to be maybe less by 20 degrees. So, sorry, not by 20 degrees, by 20 seconds. So it means that we may need to add some seconds to each and every internal angle, so that the summation of those internal angles add up to, the summation of those internal angles is equal to 360 degrees. So you could divide, in this case, you divide 20 seconds by 4, because we have 4 internal angles in this polygon. And for each and every angle that has been observed, you will be adding, that is 20 divided by 4 is 5, so you will be adding 5 seconds. However, we will discuss this much whenever we will be doing the traverse calculations. That's where now you appreciate how this is done. But as for now, we're just going to do some a little introduction. Principles of traversing. So normally when you are conducting the traversing, you need to follow the following, or these steps are followed for any traversing exercise. So the first exercise, you measure the slope length of every line. So in this case, you will see that normally the ground where you are measuring the points, or maybe the distance between the stations, will hardly be a level line. So in this case, we assume it's a slope distance that you are measuring. So if you are measuring on the ground, then we take it to be the slope length. So you measure the slope length, and also when you are measuring the slope length, it's possible you determine the angle of gradient of every line that you are measuring. Like in this case, you can see the angle theta represents the gradient of the line that we are measuring in the field. So of course, we'll be discussing this as we go along, how it is done. And also you measure the clockwise horizontal angle between the adjacent lines. So normally when you are conducting the survey, it means that you have several lines that are connected together, and then the angle between those lines are supposed to be measured. So whether you are using whether it's a linking traverse, or maybe it's a closed traverse. So if it is a closed traverse, then you are measuring the internal angles. But if it is a linking or connecting traverse, you are measuring the angle of deflection in this case. And also, finally, you obtain the bearing of the line. So the bearing of those lines have to be determined because we are saying that a traversal consists of a series of lines which are connected and have both the magnitude and direction. So in this case, we need to determine each and every direction of the line by determining their bearings. Processing field work. So after you've done your traversing exercise, your field work, now you need to do some office calculations. That is, this can be done in office or you can do it at the site if you have a place where you can do that. But normally this is an office work. You have collected the data and now you want to determine, you do some calculations. So the length between the points that you were correcting, that you were recording, that is not the horizontal length or it's not a plan length. Because if you are going to base your length on that kind of a plan length, the slope length, it may not fit on the land whenever a design has been made. But in this case, for any length that you've measured, you need to bring it to the plan length. So in this case, you calculate the horizontal equivalent of all the lines from their slope length and the gradient. So in this case, you have the gradient, and then you have this slope length. So to determine the value of this red H, the distance from here to that just below another point here. So if we were to locate, that is to say, the point lower, if it were to be A and then B, so the point below B. So this plan length can be determined, can be calculated. This is one of the office work, or that's one of the exercise that you process the field work. Of course, that can be determined either using the triangle ratios, which is normally known as, you call it SOHCAHTOA, or you can use the Pythagoras theorem. That is, if you know the difference in height between the 2 points that you were surveying. But if you don't know it and then you know the gradient, you can use the SOHCAHTOA kind of ratios. That is SOH, and then you have opposite over hypotenuse sine is equal to opposite sine theta is equal to opposite over hypotenuse. But this will be, we'll discuss this more into detail whenever we'll be conducting our calculation. But in the meantime, the intention is just to introduce you to the traversing and the activities that are involved in the traversing. But after that, we will be doing our calculations. So the next, you calculate the whole circle bearings of all the traversal legs. So you have the distance and the direction, or maybe the angles between the lines. But now you need to determine the horizontal bearings of the side. So this can be calculated. And also you calculate the rectangular coordinates of all the stations relative to the survey origin. Like I said, whenever you are doing you start your traversing, you start from one point. So that point will have the details of the coordinates, that is the eastings and northings of that particular point. So as you are moving along the site, you are doing your traversing exercise, then you are also locating the points in terms of maybe the direction and also the distance between the lines. Then finally, you also need to determine the coordinates of those points that you have established. These two will also be discussed under the calculation of a traversal exercise. So factors influencing the choice of stations, the traversal stations. You don't just choose the traversal stations anyhow, especially when you are conducting the traversal for the highways or railway lines and the like. So you need to choose those convenient stations. But if it is establishing maybe the location of the corners of a land, like plot and the like, you may not have a choice. But then where it is not possible to locate or to measure or whatever, you could devise other methods or other methods that you can use so that the exercise is perfect, or maybe the exercise has got minimal errors. So one of the factors that will influence the choice of the stations is easy measuring conditions. So whenever you are locating a station, that station should have easy measuring conditions. You normally not select a condition, sorry, a station where it is located. It is located in maybe on a cliff, or perhaps the station to be located in mud, or maybe where it is swamp, or whatever, unless it is necessary to do so. But in most cases, you need to locate your stations where you can easily measure it. And you also need to avoid the short lines. Actually, if you have the stations being located maybe 50 meters apart, that could be okay. But a station that has got, say, 5 meters apart. So if you have an error of maybe, say, 2 millimeters, so 2 millimeter every 5 meters, and you have measured maybe something to do with a distance longer than maybe 10 kilometers. So the error will be very huge in that aspect. So therefore, it is not advisable to choose the short lines. Also, you need to consider permanent referencing stations. That is where you are to locate the stations. There should be those objects that are permanent, that can easily be referred to after maybe a longer time. You should be able to locate those stations, as opposed to having maybe temporary objects, those that can easily be removed. In that case, you have lost your data. So choose those objects that will have permanent objects anyway. And also, finally, another factor that you may influence the choice of the station is the intervisibility of the stations. Of course, this depends on the machine that you are using to measure the distances. So where you need clear vision to see the other point where you have fixed your target, then those points are supposed to be intervisible. You should be able to see to see from each of the stations, even if you interchange the machines. So those points are supposed to be intervisible, unless otherwise where you are using other kind of measuring methods, like use of satellites and like. Therefore, the intervisibility of our stations may not be necessary in that case. So, like I said, traversing involves the linear measurement. That is, you measure the distance between the 2 points. That's a linear measurement. And also, it involves the measurement of angles, or observing of the angles between the lines. So one of the exercise, like the linear measurement, this can be done by EDA machines. You can measure the distance by measuring tape or tape measure, or you can use the stadia. Of course, there are other methods that you could use to determine the measurement, but we are going to discuss mainly tape measure, and also EDA machine, and also the stadia. Those are the methods that we will be discussing at this level. So the taped measurement, or maybe distance measurement using the tape measure. So there are errors associated with the tape measurement. One of the errors are grouped into two. You have the constant errors, and also the systematic errors. So constant errors can be the misalignment of the lines, and also the standardization of the tape that we are using, and again the slope. The systematic errors, we have the temperature, tension, and sag. Of course, the types of errors and other limitation of our surveys will be discussed in another lesson. So practices that you need to follow when taping. Like I said, like we have seen in our previous discussion, we've seen that whenever you're using the tape measure, there are possibilities that you may not have the actual actual distance from the tape because of the conditions of, or because of the environment, or maybe because of the incompetency of the one doing the job. So of course, maybe to avoid the practice is, one of the practices, you need to align the tape that you are doing, that you are using to measure with a theodolite. So you align the tape with a theodolite. You can use the theodolite to align the tape. And the other practice is to standardize the tape measure before use. Of course, standardization, you need to determine the difference between the nominal tape and the standard tape. So nominal, the field tape that you are going to use for the traversing exercise, and the standard tape, which is normally kept somewhere for safe, where all the conditions are standard, like the temperature and also their length. So you need to measure your field tape against the standard tape to determine whether the length will tally. You may have a tape which has been calibrated as 30 meters, but when you put on the standard tape, it might be possible that that tape is longer or shorter depending on the condition of the tape. So it is important that you should standardize the tape. You should know the error of that particular tape that you are using. However, if the tape goes an error which is even more than 0.5 meters, or even 0.4 meters, that tape has to be discarded. You cannot use it. Otherwise, it has to be very few fractions of a meter is the one that you could use in the maybe the error of 0.02. Yes, that is acceptable. But those tapes which are very defective, then you don't need to use them. They will give you wrong readings. And also, since we are measuring, we are doing the ground length of or slope length of our traverse legs. Therefore, there is need to do the correction. Of course, the plan length can be determined by finding the root of, like I said, that you use the Pythagoras theorem, or you can use the trig ratios. That's what we have in this formula. Okay. Another area of concern is the tension. So supposing that you are not measuring on the ground, but you are suspending the tape. So if you are suspending the tape, it means that you're supposed to pull the tape, because that tape will have the influence of the gravitational pull. So you may need to straighten your tape. So if you pull the tape beyond the standard tension, then that has to be as well corrected. The standard tension normally is 50 newtons, so you pull the tape at 50 newtons. So in that way, that will be fine. But where you can not pull the tape at that kind of tension, if the tension is higher than that one, then you do the correction. And another is the temperature correction. So the temperature correction the tape are normally standard at 20 degrees Celsius. So if you are to use the tape where the environmental condition or the environmental temperature or the field temperature is below 20 degrees Celsius or above 20 degrees Celsius, then you have to do some correction. So this is what I had for in our introduction to traversing. Actually, our next discussion will follow. We will be discussing the equipment that we use for taping. Sorry, the equipment, the types of tapes that we use in the traversing, and also we'll also discuss the other equipment that are used in the traversing to measure the distance. Then after that, then we'll also be discussing the calculations of traverse. That is, how do we determine the bearing? How do we determine the area? How do we determine the coordinates? Or how do we correct the coordinates? How do we calculate the change in things and all things? All those things will be discussed in our subsequent lessons. Thanks for your attention today.